record at my end.
Oh,
Hopefully,
and can we end at the same time because I have homework too.
okay. All right. So,
Okay.
all right. So it's recording now, right?
Mm-hmm.
So earlier I asked you what is the limit of what was it, x squared as x heads towards 3? So x squared
Yes.
looks like this. 3 is here. Okay.
Yes.
What are the coordinates here, by the way? It would be 3, comma
3,9.
yeah, 9. So this is 9 here.
Oh,
So
so would the limit be 9?
yeah, so you're heading towards 3 from the left-hand side. You're heading towards 3 from the right-hand side, and then you meet at 9. So we said the limit exists, and it is equal to 9. Okay.
Mm-hmm.
And then I would ask you, let's say, what is the limit of 2 to the power of x as x heads towards 0? So what's the limit of this?
Is that the one with the...
Yeah, that's that one there. And then you've got to head towards 0. So 0 is here. You've got to head towards 0 from the left-hand side, from the right-hand side. But you have to move along the function. So
The
that
height would be 1.
yeah, so you're heading towards the left-hand. You're heading towards 0 from the left-hand side, from the right-hand side. Both sides meet right there. So we said the limit is 1. Okay.
Mm-hmm.
Okay. What is the limit of 1? What is the limit of 1 over x as x heads towards 2? What's the limit of this?
Well, 1 over x looks like this and this.
Yeah.
Um,
And 2 is somewhere here. So you've got to head towards 2 from the left-hand side. And
it doesn't meet.
What?
It doesn't meet.
They don't meet? Okay, so imagine you're here, you got to head towards 2. Okay, so you're walking along like this, and then you all of a sudden you jump along here on your journey, and you're still walking along here. You see that? And then from the right hand side, you've got to approach 2. You see those 2 people do meet. They meet right here. But where is that here?
Wait, I thought... because they're meeting at 2.
Yeah, they're meeting at 2. You see?
1/2.
Yeah, so the limit is actually 1 over 2. So you simply put 2 into the x and nothing breaks down. It is the number 2. It's right there, right?
Yes.
So then if I were to ask you, what is the limit of 1 over x as x heads towards 0, then here, you can't simply put 0 in here because you're going to get 1 divided by 0. And that's not allowed. Okay, you're not allowed to divide by 0. So
Yes.
So what is the limit here? So you got to
Does
approach
not
0.
exist.
Yeah, you approach 0 from the left-hand side. You approach 0 from the right-hand side. The 2 don't meet. So we said the limit does not exist. Okay.
Mm-hmm.
So what is the limit of 1 over x as x heads towards, let's say, negative 3?
Let me see. Shoop, shoop, shoop.
Yeah. So imagine
Negative 1/3.
Yeah. So the answer is negative 1/3. So you're actually meeting right there. Okay.
Mm-hmm.
So 1 over x as x heads towards infinity. So what does that look like? So 1 over x looks like this. Oh, if you're heading towards infinity, you can only approach it in one direction because you're infinite. This is positive infinity. This is negative infinity. So you've got to approach it all the way to the right. Okay. So imagine you're here. Okay, Chelsea.
Yes.
Imagine you're there. So you've got to approach infinity. So you're walking along here. All of a sudden, you jump up here, and then you keep going on your journey. As you keep moving to the right, because as x heads towards infinity, what height are you heading towards? Where are you heading towards? Remember, the limit is talking about the height. What is the height?
Like Um,
of 1 over x. So you've got to extend the graph. What is the height
like
that you towards?
very, very, very little, trying to reach 0, but never reaches.
Yeah, so we said the limit is 0 because you're heading towards 0 as you keep on moving to the right. So we say
Yes.
here the limit is 0.
Oh, okay.
Yeah, you're actually heading towards 0. Okay, let's look at this one here. Hang on. What is the limit for 2 to the power of x as x heads towards negative infinity? So 2 to the power of x looks like this. And what does it mean for me to ask you, what is the limit of 2 to the power of x as x heads towards negative infinity? What does that mean?
That it's heading towards still
Negative.
0.
Yeah,
Negative
so
0. 0.
yeah, so you could imagine you're here walking on the graph, and then as you head towards negative infinity, can you see you're actually heading towards a height of 0. So we said the limit is actually 0. Okay, Chelsea?
Mm-hmm.
Now, I don't know if you can remember this, but tan of x looks something like this. And this here is pi over 2. And this here is negative pi over 2. I don't know if you can remember, but take my word for it. Okay?
Okay.
All right. Inverse tan is really a reflection along the diagonal line. So inverse tan will look something like this. Hang on. Inverse tan will look something like this. Take my word for it. Okay, Chelsea? Just
Mm-hmm.
trust me. Inverse tan will look something like this. And you're going to have what's called the horizontal asymptote at
Yeah.
pi over 2. And this horizontal asymptote will be at negative pi over 2. Okay? So this is our graph
Uh-huh.
of 1 equals inverse tan of x. Just take my word for it. It looks like that. Okay? We have done it before, a long time ago.
Yes. Okay.
Okay. I would ask you, what is the limit of inverse tan of x at x towards 0?
0,
How do you know?
because it's going towards 0, and that's the index.
The what? The origin.
Origin.
Yeah.
Yes.
Okay, yeah. So you're gonna head towards a height of 0. Okay?
Yes.
Okay, what is the limit of that thing? And let me erase the graph. Okay, what is the limit as x heads towards positive infinity? So you got to imagine you're walking along the graph.
Pi over
Right.
2.
Yeah. So as you walk all the way to the right, you're heading towards a height of pi over 2. So the limit is actually pi over 2. Okay? And what's the limit as x heads towards negative infinity?
Negative pi over 2.
Yeah, negative pi over 2. Okay? All right,
Mhm.
so hang on. Take my word for it that 1 over x squared plus 1 will look something like this.
Okay.
Yeah.
Uh,
What's the limit of that as x heads towards positive infinity? What is this block equal to? Give up?
oh no, I'm thinking. Um,
So imagine you're walking along that
very,
graph.
very, very little. Like it doesn't hit
What?
0.
What? It doesn't hit 0.
No, the answer is 0.
Yeah, yeah. Because if you keep moving to the right, if you keep on walking and moving to the right, you're heading towards a height of 0. So we said the limit is 0. Okay?
Mm-hmm.
What is the limit as x heads towards 0? What does that mean? And what's your answer?
Um,
What's your answer?
I'm thinking. Hold on. 1,
How do you know it's 1?
because the height as it goes to 0 is 1. Like that, the height is 1
How do you,
because
how
you
do you know
put
that height?
0 because you put 0 into the x.
Yeah, okay, cool. So basically you're approaching 0 from the right-hand side, from the left-hand side, approaching 0 from the right-hand side. The two people meet and they meet at a height of 1. So we said the limit is 1. Okay?
Uh-huh.
All right. What about this one? What is the limit of x over x as x heads towards 0? And you guys can never remember this function, right? What does this graph look like?
Boy, I remember.
X over x. What does that look like?
Let me think. It's like this.
Nope, not correct.
Oh.
Where does it jump to when it's, let's say, -2? Where does it jump to?
-1.
No. What's -2 divided by -2?
1.
Yeah, we jump to 1, which is right here.
Oh, yeah.
Yeah. What happens if it's, let's say, -0.3? Where does it jump to? Roughly.
1.
Yeah, because -0.3 divided by -0.3 jumps to 1. Okay. What happens when it's 0?
1.
No, because 0 divided by 0, you're not allowed to divide by 0.
Oh.
So it's undefined, dead on 0. Yeah. So your graph should look like this. Hang on. Your graph should have a hole in the middle, and everywhere else it would be 1. You see that? That's what your graph would look like. It's just a horizontal line with a gap, dead on 0. Okay. Now, what is the limit as x heads towards 0?
You can't do that?
So it's D and E?
Well, can't you like differentiate it to make it work?
No. Wait there. So you got to imagine one person's here, one person's here. Remember, with limits, we don't really care what happens dead on 0. I know dead on 0 it breaks down because there's a hole there, but the idea behind a limit is where you're heading towards. You see, you're both heading towards the same place. I know dead on 0 it breaks down, but you're both heading towards a height of 1. The limit exists and it's 1. I know dead on 0 it breaks down, but the idea behind the limit is we don't care what happens dead on 0. We only care where we're approaching, because really, really close to 0, let's say 0.0000001, you're going to jump to a height of 1. You get it, Chelsea? Is the idea behind the limit is where you're heading towards. I don't care what happens dead on 0. I don't care where you're heading towards. And then with this graph, I know that you're both heading towards a height of 1. I know dead on 0 it breaks down, but the idea behind the limit is we don't really care what happens dead on 0. We only care about whether the two will meet. In this case, they do meet. They meet at a height of 1, even though dead on 0 it breaks down. Right,
Yes.
Chelsea? So
Yes.
if you have a function looking like this, hang on. What was the other one? Let me think. There was another function that looked like this. I think it was absolute value of x. What does that? Do you know what this absolute value thing means?
I know that it's always going to be positive.
Yes. What's the absolute value of -3?
3.
What's the absolute value of 4?
4.
Yeah. So it's really the distance away from the origin. If you look at the number line, I would ask you, what is the absolute value of -3? It's really how far away how far away from the origin you are. So what's this distance here, Chelsea?
-3.
No, how far
3.
away?
Oh, just 3.
Yeah, it's just 3. It's really how far away from the origin you are. So let's say I would ask you, what is the absolute value of 4? What would you say?
4.
Yeah, because well, you're a distance of 4 away from the origin. Okay.
Yes.
In the future, you're going to meet what's called complex numbers. Remember this? One.
Oh, the IE stuff.
Yeah. And then
Yeah.
you've got 1. You've got I, 2I, 3I, and this is a number. What's this number here?
3I, 4.
No, it's actually the number is actually 4 plus 3I, and
Oh.
collectively, this thing here is a number. Okay,
Okay.
that is, it just happens to be a complex number. And then I would ask you, what is the absolute value of this complex number? So it's really the distance away from the origin. That's what the absolute value of thing means.
Okay.
Okay. Well, then what is the distance here, Chelsea? Remember, you've got to use
4.
No, 4 is from here to here.
Yeah.
Well, this is a diagonal, so therefore it should be longer than 4.
Oh,
You got to use Pythagoras. Remember this? 4
yes.
squared, and then this would be 3 squared
3 squared
equals x squared.
16 plus 9
Equals 25.
25.
Yeah.
25 square root of 25 is roughly.
Not roughly, definitely.
Oh, definitely 5.
Yeah. So the absolute value of that weird complex number is the number 5. Is 5 away from the origin. And Chelsea, you should remember this triangle. It always crops up in school. They'll always give you this triangle: 3, 4, 5. It's a famous right-angled triangle.
Yeah.
Okay. Well, anyway, so back to this thing here, Chelsea. This graph, if you try and plot it, what happens when you're at 3, say? Where will it jump to? Because we're trying to draw the graph of x over absolute value.
1.
1. What happens? So if you do it all along here, it will look like this. Okay. What happens when it's 0? We'll see.
It wants. It becomes
It's going to be like this: 0 divided by absolute value of 0. What's the absolute value of 0?
0.
Yeah. So it really boils down to 0 over 0, which means it's undefined. It breaks down. Okay.
Yes. Okay.
So we can't actually consider putting 0 into this function. So just know that the minute you put 0 into that, it breaks down. So there is no output. Okay.
Okay.
All right. What happens when it's -4? Where does it jump to?
1.
No. So let's put -4. No. Let's put -4 into here. That would be -4 divided by absolute value of -4. What's the answer?
-1.
Yeah. So it turns out to be -1. So if you
I forgot we were doing absolute value.
Yeah. Anyway, the function looks like that, right, Chelsea?
Yes.
Now I would ask you, what is the limit as x heads towards 0? So
it doesn't see each other.
Yeah. So what's the limit?
DNE.
Yeah, because the two people don't meet. Okay, so we say the limit does not exist.
Yes. Okay.
In this case, earlier the limit exists. Earlier when we looked at x over x, remember that, Chelsea?
Yeah.
Earlier, x over x, it does exist. It was 1, but when you look at this one here, x over absolute value of x is DME. Okay, Charles?
Yeah.
All right, what about this? What is the limit of x over x as x heads towards 3? What's the limit?
Let me see. 3 would be 1.
Yeah, because as you head towards 3, you're heading towards a height of 1.
Of
So
1.
the limit
Yeah.
is 1. Okay? What's the
Yeah.
limit as x heads towards infinity?
1?
Yeah, it's still 1 because you're heading towards all the way to the right. And no matter how far to the right you go, you're going to head towards a height of 1. Okay?
Mm-hmm.
Okay, what does this graph look like? Let's say x squared over x. Take the limit as x heads towards, I don't know, let's say 3. So what does that graph look like?
Let me think. Let's see. 1. 2 times 2 is 4. 2. Would it be like this?
Yeah, no. What happens when it's 0?
But with the circle.
Yeah, then it will be correct. Because if you think about it, let's say 3 squared, 3, they cancel each other out. So we just jump to 3.
Yes.
Right? So really, when you look at this, you can think of this as being y equals x, because x squared over x, they cancel each other out, leaving you with just x. That's why it looks like a straight line, y equals x, right?
Mm-hmm.
But it's not y equals x, because dead on 0, it breaks down. You see that? That's why we've got this little circle.
Yeah.
Okay, so the graph, this graph actually looks like this. I know dead on 0 it breaks down, but we can think of it as acting like y equals x. Okay, Chelsea?
Uh-huh.
Okay, so what is the limit of this as x heads towards 3? What's the
Through
answer, Chelsea?
3.
Yeah, what's the limit as x heads towards 0?
Can't do that. So D and E.
DME?
Yes.
That would be wrong, because if you imagine you are here, Chelsea, and another person's
Oh,
here, you could
1.
no. Well, do the two people meet?
Yes.
Yeah.
No, the whole.
No, I know there's a hole, but remember the idea behind the limit is that we don't care what happens. That
They're heading towards 0.
yeah. So the limit is that the limit does exist. It's actually 0, even though I know dead on 0 it breaks down. The limit actually exists. It's 0. Okay, Chelsea. Even though there's a hole, remember, Chelsea, we don't care what happens dead on. We don't care what happens dead on 0. Can you see that, Chelsea?
Okay. Yeah.
Is we only care about where they're heading towards. If yeah, they're heading towards a height 0. I know that on 0 it breaks down, but the idea behind the limit is that you don't care what happens precisely dead on 0.
So 0.
Yeah,
Yes.
they are heading towards 0. Yeah. Okay, Charles.
Yes.
What about this? X to the power of 5 over x to the power of 3. What does this graph look like as x heads towards 0? First, sketch a graph. What does that graph look like?
What the hell? Okay.
Okay, let's consider 2. Where will it jump to? So here you've
2
got.
times 2 is 4. 2 times 2
Oh,
is
don't do that. It's too much work, Chelsea.
16 times 2 is what? Like 38, 33, 32?
Charles, just cancel them out. So it's going to be
4?
4. Yeah.
What? Oh, because you simplified it.
Yeah. Okay,
Oh.
what happens when it's 3? So it's 3 times 3 times 3 times 3 times 3 divided by 3 times 3 times
9?
Yeah, it just jumps to 9. Okay.
Oh. Okay.
Well, if you think about it, Chelsea, you can
16.
you can simplify this as being like x squared. Anyway, if you were to sketch it, what would it look like?
Like this.
Chelsea, sketch x to. Okay. What happens? What happens when it's -2? Where does it jump to? It's not right what you drew, by the way.
Positive?
Yeah, it's positive, isn't it? Because
like this.
what is it a straight line though, Chelsea? Because this is 4, 9, 16. But Chelsea, when you simplify this, what does it give you, Chelsea?
X squared. Oh.
Yeah, so it's going to act like x squared, but it will act like x squared. But what happens dead on 0?
It breaks down, or it becomes.
So you've got a hole in the middle. So you can think of this as acting like x squared. So other than 0, everything else will act like x squared, like normal. But it's just dead on 0, it breaks down. Can you see that? So your graph will actually look like this. Hang on. Your graph will actually look like this with a hole in the middle, like this. Can you see that?
Yes.
And what happens as x heads towards 0?
It will be 0. It will. Yeah.
What? Yeah. On what? What?
The limit
What's
will
the
be
limit?
0 as it heads towards 0.
Yeah. But I know dead on 0 it breaks down, but we're talking about limits, and the idea behind the limit is where you're heading towards. You're actually the two sides meet and you're heading towards 0. I know dead on 0 it breaks down, but we don't really care what happens dead on 0. Okay. So the limits exist. It is 0. Okay, Chelsea.
Okay.
All right. What about this? X to the power of 4 over x. Take the limit as x heads towards 0. Anyway, what does this graph look like? Can you draw that graph?
Yes. It will be my favorite graph. X to the power.
Wrong.
Oh.
Dead on 0 breaks down, Chelsea.
Oh shoot! I forgot the circle.
Yeah, so it should look like this. Can you see that? It's like a cubic. So you can simplify this to being like a cubic. But just bear in mind that it's not exactly the same, because dead on 0 it breaks down, so there's a hole there. Okay,
Yes.
Chelsea.
Okay.
But so what's the limit then, Chelsea?
The limit as x heads towards 0 is 0.
Yeah, the limit is 0. I know dead on 0 it breaks down, but we don't care when it comes to limits. Okay, Chelsea.
Would you say?
We don't care what happens dead on 0.
Oh yeah.
I know
Yeah.
it breaks down. Okay. All right.
Mm-hmm.
Anyway, so let me ask you this. Hang on. Whether let me think. X to the power of 5 over x to the power of 4 with a 3 here. What does that look like?
Let me think about this one.
What does this graph look like? Okay, I'm gonna remove
No. Watch. Listen.
Yeah.
I got it. Like this?
Okay, but you don't. Well, this thing here, Chelsea, you can simplify this as being x, right? But just
Yeah.
bear in mind that dead on 0, it breaks down, and then because
Yeah.
you've got 3 there, it's going to be y equals 3x. So yeah, so basically, it's more slightly steeper. Can you see that? So in your mind, think of the graph y equals 3x with a gradient of 3. Can you see that?
Mm-hmm.
Yeah, but it's just dead on 0. It breaks down. Okay.
Okay.
All right. Hang on. What about what about this one? See, and what is hang on, x to the power of, let's say, 3 plus 3 or plus 2 divided by x.
X
What
squared plus 2.
what happens when it's very, very big as x heads towards infinity?
As X toward
Yeah.
infinity.
You got to imagine these two bubbles getting very, very, very big. Okay, so hang on. I don't know what this graph looks like, but really, I only care about what happens when x gets really, really big. Just
Oh,
on
when X turns really, really big, the number will be really, really small.
no, you're thinking of 1 over x. You're
Oh,
thinking of 1 over x. Hang on, Chelsea. I'm going to change your question. Hang on, I'm going to change your question. I'm going to ask you this. What's x squared over x to the power of 3 as x heads towards infinity? What is this,
what the
Chelsea?
hell?
What is it to?
Negative. That's negative X1.
What?
That's negative X, right?
Where? What do you mean negative x?
No, when you simplify this.
Oh, you mean x to the power of -1? You mean? Is that what you meant? No. Well, if
Yes.
you were to simplify,
No.
all right. How would you simplify this, Chelsea? What is that? How would you simplify that? Do you know?
No, I don't know.
Okay,
I don't
so
remember.
x squared is like being x times x, and then divided by x times x times x. Can you simplify that?
Oh,
Yeah.
1 over X?
Yeah. You see, this thing here will act like 1 over x.
Okay.
Okay, Charles? And if you don't believe me, jump to Desmos, and punch in x squared divided by x to the power 3. And it will draw a 1 over x graph. It should. Oh,
Wait,
small
X.
x. X
X what?
divided by x to the power 3.
Divided by X to the power of 3.
X to the power 3. Yes. Now next line, Chelsea. Next line. Next input. Do 1 over x. Punch in 1 over x. Okay. Yes. So now hide it. And you see they're both the same. They act as if they're the same. Can you see that, Chelsea?
Oh, yeah.
Yeah. So back to iDrew. Jump back to iDrew. So you can simplify this thing as this. So it's like me ask. So what's the limit as x heads towards infinity? Chelsea. What's the limit of this, Chelsea? Are you there?
Wait, no, I'm thinking. 0?
Yeah, because really the graph looks like this. Even though it looks slightly complicated, but it acts like 1 over x. And I know that as you head towards positive infinity, you're heading towards a height of 0. Okay, Chelsea?
Yes. Okay.
What about this, Chelsea? What about this? To the power of 5 down here. Pound to the power of, and I'm going to change this. To the power of 3 to the power of 5. What's the limit as x heads towards infinity?
What do we think? Five, 4, 3, 2, 1 over x. It would be like well, if you simplify it, it would be 1 over x squared.
Yeah.
0?
Yeah, but why? First,
Because if you did take away the 2 and you had 1 over x, it would be 0. And if you put 2 on it, which times it by itself, it would still be the same.
I don't understand your explanation.
Me neither.
Anyway, because we're running out of time, 1 over x squared looks like this, Chelsea. I don't know. We have done this. You got to trust me on this, right? 1 over x squared looks like that. As you head towards the right hand side, and you see you're heading towards a height of 0. You see that?
Mm-hmm.
So, and another way of thinking about this, Chelsea, is what happens when you look at a really, really big number. Let's say 1,000. Okay, Chelsea. If you put 1,000 into here, it would be 1 over 1,000 squared. Can you see that, Chelsea?
Mm-hmm.
Well, 1 divided
Oh,
by a really, really big number, it's going to be a very, very small number.
yeah.
And then if you extend this to 1 million, Chelsea, 1 over 1 million squared, can you see? You're going to have 1 divided by a very, 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 very big number, making it to be really, really small. So basically, whenever the index of the denominator is bigger than the index of the numerator, can you see the limit will be 0?
Yes.
Yay or nay, Chelsea?
Yay.
That's why even in the case of 1 over x, as x heads towards infinity, it's still 0, because imagine you put 1,000 into here. Sorry, as x heads towards infinity. Imagine you have 1 over 1,000. That's going to be a really, really small number. Okay, Chelsea?
Yeah.
So in summary, if the index of the denominator is bigger than the index of the numerator, you know it's going to head towards 0. Okay?
Yeah.
Anyway, we call it a day here, Chelsea. We still need to do more on limits. Well, we will continue next week. Okay, Chelsea?
Okay.
Bye-bye, Chelsea.
Bye-bye. See you next week.
How do I turn this thing off?
I'll just hang up and then it'll
No,
stop.
don't. Wait, Chelsea, don't hang up. Let me hang up. How do I stop recording?
You go to where you started the recording and then do the same thing you did as you started, and then you'll see that it says stop recording.
Wait there. Wait this. Okay, wait there. Do I just hang up?
Boy, okay. You
No,
know how
stop.
you press start recording?